In this lesson, you're going to discover the relationship between parallel and perpendicular lines. So I would like you to pause the video and count the slopes of the red, blue, and green line you see in the graph. So the red line appears to be up 1 and right 3 units to have a slope of 1/3. The blue line is also up 1, right 3 units to have a slope of 1/3. And the green line is a downhill line going down 3 and right 1. So down 3 would be -3/1, which is just -3. Now, what is the relationship you see between the red and the blue lines? Hopefully you notice that these are parallel, meaning they would never ever touch one another. So what conclusion can we draw about their slopes? Well, I have the same value for both. So my conclusion is the slopes of parallel lines are the same. Now, perpendicular lines, notice that one is positive and the other is negative, meaning that they are opposites. And then if you look at the numerator and denominator, it's easiest to see that it was 1/3, and this relationship, the numerator and denominator flip. So I have perpendicular lines in the image, and they are what we call opposite reciprocals. So let's make sure you understand what I'm saying. If a line has a slope of 1/5, if I were to draw another line parallel to it, it would have a slope of 1/5, and the perpendicular one would be -5/1, which is just -5. Let me also point out the parallel symbol. It looks like a skinny L, double L, like from the word parallel. Perpendicular is like this upside down capital T. It's easier than writing out the whole word. So if something has a slope of -2/3, a parallel line would also have a slope of -2/3, and the perpendicular slope would have a backflip, and it would become positive because it's the opposite. The one that's sometimes tricky for kids is if the slope is -1, the parallel slope is also -1, and the opposite reciprocal would be +1, because when one does a backflip, it would stay 1/1. In example A, we're given line G and line H. So I'm going to begin by counting the slope of line G. And I'm finding where it hits in the corner. So it looks like to me it's down 2 and right 5. So G would have a slope of -2/5. Line H down here has a slope of 0 because it's horizontal. So I'm asked, what is the slope of any line parallel to line G? Well, that would have the same slope, -2/5. Why don't you pause the video and see if you can answer 2 to 4 and then compare your answers with me. So for number 2, the slope of the one perpendicular to G, well, the perpendicular slope, it's going to do a backflip. Here's the reciprocal, and opposite would make it positive. Slope of the line parallel to line H, so my parallel slope is going to be the same. And if I were to do the slope of the one perpendicular, if I were to make 0/1, if I do a backflip, that becomes 1/0, and I cannot divide by 0, so it's undefined. But hopefully you kind of knew that already, because if I were to draw something perpendicular, it would be vertical to make that 90-degree angle. In example B, we're asked to make the conclusion if the lines are parallel, perpendicular, or neither. So hopefully you recognize that you're going to need to be finding the slopes of these lines. So you're going to need to do your slope formula where you subtract your y. So if I do 2 minus -5 over 6 minus 2, that's going to be the same as 2 plus 5 or 7 over 4. And then if I do my second line, be 4 minus -3 over 8 minus 4 gives me 7/4. Since the slopes are the same, my conclusion is the lines are parallel. I'm going to do the same in number 2. So pause the video, find the slopes of the 2 lines, and then see if you can make your conclusion. For the first line, I get a slope that is undefined. And for the second line, I get 1/5. So these lines would be neither parallel nor perpendicular. They would just intersect somewhere. And then number 3, again, you need to calculate your slope. I do -4 minus -2 over -3 minus 5. That gives me -2 over -8, which reduces to +1/4. For the second line, I would have 4 minus 8 over 6 minus 5. That gives me -4 over 1. So when I compare these two values, I see that they are opposite and they are reciprocal. So my conclusion is that I have perpendicular lines. And again, I'm using the symbolism because it's faster than writing out perpendicular. The last example here says, draw a line perpendicular to the given line that passes through 2, 3. So if I needed to be perpendicular to this given line, I'm going to start by counting the slope of this line. So it intersects here and here. So it looks like up to right 1. So up to right 1 would be 2/1 or 2 for my slope. So the perpendicular slope needs to be the opposite and the reciprocal. So -1/2. It's going to be my new line. But it also needs to go through this ordered pair 2, 3. So I'm going to graph that by going right 2, and up 3. And from there, I need to count a slope of -1/2. So I'm going to go down 1, right 2 from that point, or up 1, left 2, to get a bunch of ordered pairs that will permit me to sketch a very straight line even without a ruler. And I can see that they intersect from a 90-degree angle. Okay, please reach out if you have questions about finding whether or not lines are parallel or perpendicular based on their slope.